Thank you very much and good morning. I hope you all have you all read the abstract today, not yesterday, because they put up the wrong abstract on the website. It has nothing to do with exploration of language, but about domain-driven design and user interfaces. So I was already introduced. I love building business software, and I've been doing business software for 12 years now. In the last 6 or 7 years, I'm helping other companies to build CQRS and event sourcing systems and introducing modeling techniques like event storming and doing domain-driven design overall, even have my own conference in Berlin. So that much about me. We're going to cover some ground today. We have 45 minutes for 4 rough topics. It's domain-driven design, talking about architecture, user interfaces, and visual design in the end, and connecting it all together. If you have any questions in between, just raise your hands. I'm going to rush through this very fast, but I have time for questions, so if you need clarification, just shout out. So domain-driven design. What is domain-driven design? Who in the room has heard of domain-driven design or practiced it? Oh, almost everyone. That's great. Okay, so that's covered shortly. Domain-driven design is a book by Eric Evans, and it sparked a whole movement. So for the last 15 years, there's a worldwide community growing, doing lots of conferences and meetups, and there's now, I think, 10 different books by Alexei Zimarev and Adam Dimitruk and Greg Young, and it's a growing topic about focusing on the needs of the customers first and exploring their natural language and putting that language into modeling and into code. And also on building the architecture of your software aligned with the business needs and not with technological needs. So that is a basic idea of domain-driven design. And there is something called Conway's Law. Conway's Law states that companies are prone to reflect their communication structure in the systems they build. And this goes both ways, meaning if you have teams that don't like each other, their components are probably not communicating very well. There will be anti-corruption layers and protective surfaces. If you have teams who have a highly distributed way of communicating, they will most likely not build a central server system that is organizing everything, but they will have something that is more resilient. So what we need to do is figure out what our customers actually want, and we need to build something that, we need to build a system that is surrounded these problem spaces and not our technical expertise. So we don't want to have a database team and a UI team and a domain team. We want to have cross-functional teams that can care about shopping, warehousing, delivery, payment, or wherever our subdomains might be in our business. So when we have our context clear, when we know what we're actually trying to solve, and we can structure these into smaller bounded contexts, we need to figure out which of those contexts is our core domain, which is it where we actually want to shine, where we differentiate ourselves from the market. Once we know what our core domain is, we can put effort in the supporting domains just enough to make the core domain succeed in the end, but the thing that we're actually trying to build is our core domain. So we will not build one architecture, one infrastructure for everything that we put together, but we will focus our most deepest analysis, our best architects and the smartest minds into the core domain. And the supporting contexts, they are individual, they are unique to us, but we just have to build them well enough so that our core domain can shine in the end. And sometimes we have generic contexts like payment. Most companies can just use PayPal or some credit card services and are done with it. Unless you're PayPal, then payment is actually a core domain, of course, but anywho, once you know your core domains and the relationships between the contexts, we also map out the relationship patterns, like is it an upstream or downstream relationship, who owns the model of the relationship, who is dictating how the communication works. And most oftentimes the core domain is upstream because when the core domain changes, every supporting domain has to adhere to that. But a generic domain, for example, if it's a software that we bought from somewhere else, is upstream because we cannot negotiate the model. The bought software dictates how we use it, so we have to change ourselves. And therefore, there are some patterns that help us in defending ourselves. So if we are downstream from some other context, we can build anti-corruption layers, and there's a whole bunch of more relationship patterns to explore in the DDD books. But just a general knowledge, it is important to know the relationship you have with the other bounded context to understand what forces will drive your software and your design in the future. And this is not just a technical thing, it's a socio-technical thing. So the relationship between two bounded contexts is the relationship between those teams. If they are pairwise relationships, they need to be co-located or have a very high bandwidth way of communicating when they remote. Upstream, downstream can rely more on contracts. And if we're defending ourselves with an anti-corruption layer, those teams don't even need to know each other. There's just something in between that can translate. That can be people, organizational diagrams, can be technology. So let's focus on a core domain. And what DDD says is a new idea from the book. I think it's the only new idea from the domain-driven design book. Everything else is just things that have been said before, but put together in a good way. But the new idea was to have one ubiquitous language per bounded context. What does it mean to have a ubiquitous language in a bounded context? That means that every word that is said or written in that bounded context has a unique and deterministic meaning. It's very clearly defined. So if you have a customer in shopping, that customer has certain information, it has certain behavior and interests. If you have a customer in payment, that's basically someone who is owing you money or you owe them money, but it's a different thing, it's a different concept. So you can use the same words, but they mean different things, or you can use different words and they mean the same thing in one bounded context. That language has to be clearly defined, but the other people from the other context don't have to share the same ideas. So you don't need one word that is true for the whole software and for the whole system, but inside of a bounded context. And ubiquitous means it's not only in the code, it is in the heads of the users, of the business people and experts, of the programmers. These words are used in code as well as in documentation and in marketing. Marketing is the only place where you can say, okay, because the outside world is a little more fuzzy, in marketing you can change, but if your marketing expressions completely differ from what you're internally using, you have a different problem right over there, and this is something where domain-driven design even can help you analyze that. So we have one team per language, so we can, one team, one language per bounded context. That means there can't be two teams inside of one bounded context. One team can have multiple bounded contexts, of course, but if you have two deliberate, distinct teams that work in the same bounded context, there would be two teams building the same model, but without talking to each other. That doesn't work. That's physically impossible. So if they are doing that, that's actually one team for that moment in time. So you can only have one team per bounded context, and they need to make sure that they share a common language, which you usually derive in 3 steps. You have your natural language, French, English, German, and then there's a business language inside of that, and from that business language you have to define a ubiquitous language together. So if there are multiple competing words, if there's some ambiguity, some people say employer, employee, some say colleague, do we mean the same concept? Great, now we have to define, oh, this is a word we're using because this is what our code will look like in the end. We need to understand what we mean when we are in this context. What we're trying to do is reduce the mapping between what business people have in their head and what programmers see when they look into the code. So when business people talk to me, I'm a programmer, right? When they talk to me like, hey, Marco, at the end of the year, you know, the fiscal and blah, 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 this needs to get transferred to, great. I'm looking into my code, okay, for I to do something, SQL, Docker container, whatever. That's not that. So now I have to compile in my head. That costs a lot of energy, and it's very error-prone because we humans make mistakes. And I don't want to waste my time compiling in my head what I see on the computer. I would just want to read the code and understand what it means. I want to listen to business people and then find those concepts in code to actually figure out, oh, yo, what you're telling me is not what the code is actually telling me. So let's talk about that together. Ideally, you can just look into the source code together with your business people and both parties understand what's written there. So the shortest possible mapping would be 0. We're not there yet, but we're getting there. So I brought a nice domain, a very well-designed ubiquitous language. Who has written language like this? Who's lying? Great. Okay, so we have these typical object-oriented put-together words that are a mix of domain terms, but also technical patterns. You have a container pattern, singleton pattern, a delegate. Great, now we know what we have in code, right? It's important to know what you have. If you don't know that this is a repository, how would you use it? That's bullshit. You don't need to see the word of what it technically represents, because we have IDEs. If we want to know what it is, we can just hover over it or step into the thing, but what we want to read is how the code is used and what it means in domain terms. So we need to get rid of those weasel words that bluster our code and that obfuscate our understanding. Is it better now? Not really, right? So we have multiple problems now. The multi-but supporter just became a multi-but, and that's definitely the wrong concept. So when English is your domain language, there's a problem of some terms meaning something in a technical manner and in your domain. If you actually build factories and you have a factory, at some point that hurts in your head because you don't know what you're talking about. If you're an event manager and there are events in your code, then you have an event like this is really hard to understand. Is it a technical term or do we talk about domain here? So what we actually want are these words. We want to understand what the business people use. So you have to talk to customers, to domain experts, to get a grip of the real language. And once you understand, oh yeah, it's a picture and a sofa and a couch, this is what we're talking about, great. Then you found the right nouns for your entities, but be very aware, DDD is much more than just nouns. It's about the whole terminology, it's about expressions, about verbs, about the language that flows, not just, oh, this is a table. Okay, so brought a little code example. Show you quickly how this looks. This is a customer repository, and it has a wonderful getter. It says get customer by year of birth with a date, time, year of birth. And there are many things we can get rid of in this code to make it more domain-driven. To have a good ubiquitous language, customer repository is just a pattern. Get rid of that. A customer repository just represents a list of customers, so call it customers. And getters and setters don't mean anything in domain-driven design, so just get rid of the getter. Then you have customers, customer by year of birth. Oh, there's still redundancy. We don't need customer by, so customers by year of birth. But who speaks like that? Have you ever had a domain expert come in a room and say, hey, give me the student list by year of birth? Nobody says that. So what we actually want to have is customers born in, and we don't have primitive data types in our domain. There is no int. There's a year. So we build our own constructor, a factory function that's called year of, and then we can build code like this. Instead of saying a repo is the customer repo and then C is repo get by year of birth, new date times some numbers, we now can say all customers turning 50 is all customers born in year of 1968. That's a neat trick from the DDD book. It says model out loud. When you can speak your code and it makes sense to your brain because you're using normal language, then it makes sense to other people as well. And of course, this is really hard to get into the head of some programmers and to get it into the hearts of programmers because programmers are used to writing code as they do it, so they will defend it and say, but we always don't care. If I write a story like this and I have 20 lines of code and it's just a story and I can understand what's happening, that is so valuable because writing, I'm doing once, but reading, I'm doing so often that it's really important to get that understanding right without all the overhead. So for the Germans under this audience, this is how my domain looks like. I wanted to bring you some great examples, but problem is I'm writing my domain code in German, actually, because we're building software for hospitals in Germany, and their domain language is German. So you don't have to understand this. It's just to show the example. If your domain is French, in French, write your domain code in French. If it's English, you can't get any benefit from that, but then at least you know about it. So if you write code for a different domain in a different language, use their natural language, because that's the terminology the business people actually use. You want to do code in harmony with the business people, and you want to have a high internal trust in your team. So the business people, the testers, the product owners, the developers, they are one group. They shouldn't fight each other and try to defend each other from one another. They should model together to try to understand. Software development is a learning process, and we need to learn about the business all the time. Building software is just something we do, but the code is not the asset. The code is a cost we carry around to solve a business problem. So we want to build our code so that we are safe from external influence. I don't want to change my domain code just because some infrastructure gets updated or just because we're using a different database layer now. My domain is the purest thing. So in my core domain, I put every effort in I can to protect the code and the model from any external influence. So much for the DDD introduction. Let's go to architecture. So classical architecture, wonderful 3-tier architecture. You have an application and then a facade in front of your domain, and then there's some kind of persistence. So be it SQL or whatever you use, or modern day cloud storage. But this is a very, very modern 3-tier architecture, and it makes the user super happy, right? Of course not. So we're looking at an application, and this application is just the UI that shows you all the data, and you can edit it and save and load. So where does logic reside in this model? In the domain, right? That's where the logic belongs. But because you have so many information that you need to load into the user interface, it's really hard to always send everything back and forth just for a little validation. So some logic also goes into the application. because you want to validate on time while you're typing, and that wouldn't be possible otherwise. And some business logic also goes into persistence layer, because that's where your data resides. And whenever something is added to the database store, some trigger kicks off a stored procedure, and you have some business logic that runs on that whole thing. And a little bit of logic goes into the head of the user, because the user learns after a while in your software that if they didn't click here, they shouldn't do this, but if they did this, then they need to click shift, and then it works fine, right? Cool. So that's good, but that's really hard to refactor. There is no JetBrains for actual brains, so if I'm refactoring my domain, I can reach every code, but I can't really reach the head of the user. And of course, if I'm translating through different languages, SQL in the back end, C# in the domain, JavaScript in the front end, it is really, really hard to keep those concepts in sync. So we want to have it in the domain. So far, we have a problem. This application is not really task-based. What we have here is just a list of information, and if you added them wildly and say save, you don't know what happened. So the first trick to do is, in this architecture, make your user interfaces task-based. Instead of having just a grid and some checkboxes, get rid of the checkboxes, put in some buttons that actually express your need. What you want to do is dismiss someone, so make it a dismiss button. Once you click it, there's a task-based user interface just for this one specific task. So this task-based user interface says, hey, you want to dismiss Marco Heimeshoff, great, provide a reason, then you can dismiss him or cancel. And how do we build our architecture now? Because this is not CRUD anymore. We can't just say update. We could say update Marco Heimeshoff in the domain, but there's a better way, and that's CQRS and event sourcing. So Greg Young and Udi Dahan, roughly around 2008, 2009, came up with this idea, independently of each other, to split the dependency, to split the responsibility of the command side and the query side in your architecture. So not just to build one object model that solves every problem, but to build multiple object models to solve the specific problem you're having at hand. So when in my task-based user interface I send a command, there is an object model that just deals with this command, but I can never query this object model for information that I want to show on the screen. My command handler handles it by giving it into the domain. The domain says in the end, oh, something happened, so Marco has been dismissed. That event gets published, and a read model gets updated, and the read model is an object model that has just the right structure that I need to query for my screen. This architecture has a lot of benefits. So we have poly-structured information if we want to. On my user end, I just need a list of all my contracts. Great, so there's a read model that is just a list of contracts. Someone else needs to know how many employees have been fired this year. So there's an actual read model that just has this information in exactly the way that the screen uses it. So whenever something happened, you can project it into every read model, and the information is already projected. You don't have to join anymore. This makes most queries super, super fast, and most read models very easy to understand. And you have a very, very lightweight connection between the user interface team and the data team. So if I'm designing a user interface and I say, I need more information, people can just give me the information in whatever form I request, and I don't have to understand how their data storage is actually working. So the idea here is that the command handler is the translation layer between the infrastructure and the domain. So when I'm sending a command that's a technical message, I'm saying, hey, dismiss this user or this customer, Marco Heimeshoff, this employee in this case, Marco Heimeshoff. This command comes via REST interface or as a 0MQ message or whatever pattern you use. And the domain, the command handler has to know, okay, this domain object, the dismissal service, is actually handling this behavior. So I know what object to load from database. I know how to do it. And in the case of event sourcing, I'm not loading an object from any kind of storage. I'm reading everything that happened in the past. I'm reading all the events, and the state is a projection of everything that happened. So if there is an employee service, and the employee service says, oh, hired Marco Heimeshoff, hired someone else, dismissed someone. If I want to know who's in the company at the moment, I just need to go through all those events, and I can project my state. So the domain model is the purest form and is completely free of dependencies from technical structure. It doesn't need to know where the data is stored. It doesn't need to know what message layer is used. The command handler is taking care of that. And the domain model is just a pure model of rules in our domain in perfect ubiquitous language. So as a rule of thumb, no primitive data types for the domain model is a very, very easy way to make sure that you're actually building a good ubiquitous language. So from the CQRS pattern, now we know how the backend works, right? We have a task-based user interface. We send stuff. We send go back one slide. We send commands to the server. There's a command handler dealing with it. At some point, we can query the read model side because everything is updated. Super great. But how does it translate to the user interface? Where does the user interface live in the domain-driven design world? Well, in Eric Evans' book, nowhere, because presentation layer was the one thing that they didn't care about in 2003. I mean, they cared about it, but it was not the core of the problem that domain-driven design solved. So you had a lot of focus on language and architecture and modeling and strategic tools, but nothing on presentation. But with modern days JavaScript applications and with web applications that are eventually connected and with more and more fat things on your mobile phone, this becomes more and more important. And in reality, the domain doesn't live on the server or on the client. The domain is just a conceptual code model. The domain can be on the server or in the client or wherever you want it to be. So a user interface is basically just part of a bounded context. When you say, in my shopping, I have a shopping cart, that shopping cart is part of that bounded context. Because in that shopping cart, you have terms, you have constructs, you have structures that have names. These names mean something to people in shopping cart. Payment, the same thing. You have your payment, your overview, all those terms in there, all those data points, they have meaning to people in that team, not meaning to people in other teams. But then there's this problem of the user journey. User journey very often touches a lot of bounded context at once. So one possible way is to say the user journey is its own bounded context. In that bounded context, every word has specific meaning. It can be related to the shopping context or to the payment context. It can even be the same word, but it's defined as in the user journey. These terms mean the following thing, and this is what happens here. This is a behavior we're trying to protect. And the user interface is part of that bounded context. So if you build a user interface, if you build an application, and you want to make it as well protected, you want to have language that is derived from the domain, and you want to have a message-driven, functional, very clear distinction between the behavior and the infrastructure side, the Elm architecture is a very good pattern for the front end. And the Elm architecture has a code model which is immutable. It's a non-changeable code model that describes the whole state of your application. And you have a view function, and the view function, when it gets a new model, just renders the model descriptively. So depending on what's in the model, if you say, okay, Marco is dismissed or non-dismissed, if Marco is dismissed, it's gray. If Marco is non-dismissed, it's white, and it has a button that you can click. So you just have a descriptive view model that renders the model data that it gets provided. In that view, when you hover over something, click on something, when you do anything, you do not change that model. That model is immutable. What you do is you send a message to the runtime. You say, hey, I clicked this, or I want to do something. I want to fire Marco. Cool. And the runtime knows, hey, there's an update function. Let me just give that update function the momentary model, like this is a model we have, and the message that just got sent, dismiss Marco. Great. And this model, this update function, returns a new model. It doesn't update the old one, it just returns a new model, because a new model, the model is immutable again, and this new model gets rendered through the view function immediately. So doing that in a circle means you have a fully functional, very safe, and clearly understandable domain model. Your behavior resides in the update function. The render logic, how to represent this data, is in the view function, and the actual structure of information you are protecting is in the model. So now, because no application makes any sense when you cannot talk to the outside world, there needs to be kind of like a back channel, right? I mean, the server needs to send us an initial data, or when we say, hey, fire Marco, this needs to take effect outside of our application. So the runtime actually can say, look, this needs to happen on the outside world. I'm sending messages out or in, but whenever something happens, the runtime says, oh yeah, the server sends me back new information. I'm just calling the update function to update the model, and that triggers a new rendering of the view. This works really well together with event sourcing and CQRS, because on the server side, you send commands, behavior happens, an event gets published, and then notification goes back. This triggers a runtime to say, hey, update function, do something. Great, now it's rendered. Once someone clicks something, we send a command back out, it goes to the domain, an event gets published, and you have this infinite circle of messages that just go around, and you can build fully functional, highly immutable system structure that's just based on language, on messages that transfer intent. So the Elm architecture as a visualization, something everybody knows, like you're in a theater, and the model is a representation of your business, and then you have the update function that changes something, and then the view is that what the children can see. And when the children send a message and they say, hey, do this, kill the dragon, the update function changes the model again, and the view is a representation of that data. So far, so simple. Another beautiful thing is, in CQRS and event sourcing, you have a read model that projects events into a state. This read model often includes or is even equivalent to the model in the front end. So I have my shopping cart in the front end, right? It's a list of products that I am buying at the moment. In the back end, in the read model, there is a dictionary of customer ID to shopping cart, which is a list of items people are buying at the moment. So these models are so similar, they need to be able to be derived from one another. As an application, I need to query this read model and say, give me the shopping cart for this ID, and whatever comes back, I need to represent. And again, as with ubiquitous language, the shorter the mapping, the better. If I can get this mapping down to 0, that would be really great. So using the same programming language in front end and back end is a high benefit here, because then you can just reuse the model. Shared behavior, the same thing. In my update functions, I have behavior like validation logic. Nobody that's called Kenny Bars is allowed to buy more than 5 products at the same time. We need to adhere this rule in the back end as well as in the front end. In the front end, I validate stuff and I won't allow you to click the button, but in the back end, I still need to make sure that if this happens, this rule is also protected. So we can reuse our behavior when we have a function that we can just move around. Instead of having a stateful object, if I have immutability, I can reuse my functions everywhere. So let's implement some information. I'm using F# as a language here, because functional programming is easier if you use a language that actually supports functional programming first. Who of you has written functional code before? It's getting more and more itchy. Okay, that's almost a third. Okay, so we have some types. These types are immutable by nature. And let's say we're organizing a conference. We have a call for papers that it's either not opened, opened, or closed. We have a voting period. And then we have a conference with all the information inside that represents the state of my conference at the moment. In the read model, we have the same thing. Maybe we have a list of those conferences because we can build a conference organization software that supports more than one conference, but we have the exact same data model. Using F# in the front end and the back end means I can just reuse this type, and I can serialize it, send it over the wire, and reuse it in the front end. If I'm projecting the state of this object, of this type, I just have an apply function that starts with an empty conference, and whenever an event happened, I just go through, hey, look, is that event of type organizer registered? Great, then return a state with a new organizer inside. If it's call for papers opened, then return the state, the momentary state, but with call for papers is open now. Depending on the language you're using, this code is more or less code, but the meaning is the same, right? So I'm choosing F# for a variety of reasons. The first one was we use C# already, and F# is just a natural fit if you have .NET. And this language is very non-verbose. I can be really domain-driven here because I don't have to write an equal operator and a constructor and all those. I can just write what I mean. But whatever language you use, find the best way to represent the concept with as little code as possible. And when you have a projection that says, here's a list of events, this is how you get to a state from a list of events. A state and a list of events become interchangeable. So I can query the read model side and say, give me the state, or I can say, hey, give me all the events, and I'm going to project it myself. Why would we do that? Let's imagine we have an application that is mobile ready. We have it on a tablet or on a phone, and then we're disconnected all of a sudden. Connection broke. So without a connection, we're not able to work anymore. We can still look at the data at the screen, but we can't really do stuff. But if the whole business logic and the projection logic is already in the front end, I can just say, okay, look, when I start up the application, I don't want to reroute all the events, right? I just get the momentary state from the server. But everything that happens ever since, I can project myself. I don't need to send a command and wait until it's projected and then get the result. I can do the projections myself. Once I'm connected again, I can actually query the real read model because who knows what other people did in the meantime. And then I have to merge, of course, at some point. But I can work with the exact same logic, and I know it's working because it's the same deployment. For behavior, the same stuff. So we have a unit test here that says you can finish a voting period of a conference once it's open and the call for papers is closed. If you say finish voting period, then you expect the result as voting period was finished. So the execution, our behavior here, is just a function that gets the whole history of events, everything that happened, or as we know, You can also get the state because it's interchangeable. And the command, what to do. Okay, dismiss Marco, call for paper, open, do this, do that, whatever. You can match the command with the type of command that you expect, and then execute that behavior that you want executed. And you can do that again in the front end and in the back end, all given that you're using the same language, which is not always possible. So this behavior is just publishing events. So when we say, hey, reopen voting period, we figure out if the data matches, the conference call for papers is open and the voting period is finished. So in that case, publish the event, voting period was reopened. In all other cases, we say finishing is denied, great. So our behavior is just publishing events. In the backend, that makes sense. The command handler says, hey, great, let's check the state. Yeah, all rules are met, so publish this event. And then the read model projects this information. In the front end, when we're disconnected, we can do the same thing. We can send a command, realize, oh, the command doesn't go out to the server, god dang it. So we're in draft mode. We can do it in our local loop. We don't need to go to the server. And this allows us the what-if scenario as a feature. So we not only get the protection of if we are disconnected, we can still operate for a while, but we also get the feature to say, look, I have a very complicated domain here, and I want to see what would happen if I do this and this and this and this, but I don't want to actually do this on the data of the business. I just want to experiment and see what the result would be. So let's hit up the what-if button, and now we're in draft mode. The components with the green box around it, like those we can just manipulate stuff and do a lot of things. All those commands get executed just locally. And when we're done, we can say, wow, this looks great. The result I like, so make it happen. And in that moment, you have a choice to send all the commands that you did to the server and deal with collisions over there. Or you just take all the events that you produced locally, send them to the server, and deal with the collisions over there. It's two different kinds of collision dealing that you have to do because commands are intentions of users. So I say, please do this, please do that. And maybe this doesn't work. So this has other problems than if you say, oh, these things happened on my side, facts, you can't deny them. Now we have to compensate. But for both, you need to find a strategy that matches your domain expertise and your domain needs. But you can now work locally in drafting mode and make it happen, or just forget about it, and then just request the new read model after you're done. So how do you keep those things sync? All these great features, you have the same programming language, great, but what if you don't? What if you have JavaScript in the front end, or C# or whatever, and F# in the back end, or another language? Well, you could hope. You could just keep them and think manually, cross your fingers, and you'll find the bugs if there are some, at some point eventually. Just hope you don't make any mistakes. Well, that's not a good pattern, of course, because guess what humans are really good at? Making mistakes. We will guaranteed make mistakes every time. Whenever you can automate something, automate it. So code generation is something we tried for a very long time. Just generate your code. Just is easily said, but build something that scans your code, or write your own meta language that describes what you want, and then generate C# from there, and JavaScript and Java and whatever language you want to provide for. That is pretty easy for commands and events and queries because those are just messages and you can generate data types. But for behavior, this gets more complicated. You need to analyze the abstract syntax tree and then build that behavior in another language. This can get so complicated that you at some point need a team to support that code generation. So we started doing that, code generating JavaScript and C# code from a small F# domain model. And after a while, we realized this is really horribly hard work. We have to more and more and more effort into it. And then we found Fable, which was awesome. Fable is basically exactly that, but people did it already for you. So Fable is an F# Babel. It translates via Webpack. You write some F# code, and it generates even readable JavaScript code, but we don't care about the readability because we generate everything. So we generate our whole front end. This obviously is only a solution if you are in an F# backend. If you have any other kind of backend, find a good code generator that generates JavaScript from your code base, or build one. So depending on the level of ingenuity you want to put in, this can be worth it or not. In the core domain, it's almost always worth it because your core domain is independent of programming language. If you have something that just exists for a short amount of time, or where you don't put a lot of effort in, then of course don't build a code generator because you will spend more time building that than your actual business. Okay, so let's go to design. What does design have to do with domain-driven design? Oh, wait. Now we have an ambiguity in the word design. In this phase, I'm not talking about the strategical design of software, but about the visual design, like what a designer does with paint and paper. So when we design something, we use HTML and CSS as a de facto standard nowadays to design our visual user interfaces. And here in this case, I have a vacation request for a shift planning organization. And if an employee wants to take a vacation, they can request it and say, look, this is my name. I want to go from this date to this date on a holiday. Cool. So this request can be still in drafting phase. I'm just drafting the request. I can change information. And at some point, I say, OK, request it now. And then it's in a requested phase, and I cannot change it anymore, because now other people have to look it up and say confirmed or not confirmed. So it would be not so good if I can change the data in between. So this is pretty easy to understand. It's just a few lines of code. And I have a div that is kind of like a rounded shape with a padding of 4 and a shadow. It contains, depending if I'm in drafting or in requested mode, it contains 3 divs showing me my name and telling me, hey, you can type in your data here from 1 to n, or it shows me the data that I already have chosen. Great. But this is, first of all, it's hard to parse. My brain has to parse it again. I have to read a lot of code for very little semantic content. And it's error prone because we have duplication in here. We don't know why there's duplication. You know, don't repeat yourself doesn't mean you should not repeat code at all. It just means you shouldn't repeat concepts. A concept should have only one place in source code where it resides and not multiple. So at very first, let's make it semantic. Our class is actually a request form that we have here. Every request form for vacation requests and other requests should look the same. So people have a feeling of, oh, this visual language is part of my domain, right? This is a typical design of a request form. Great. And then we have these input fields like white text, black text. Let's just say this is an immutable input instead of background white, text black. And for the from and until, we have a watermark. So we're just extracting those CSS classes, putting them in a semantic class, and this semantic is not built on the component it represents, but is built on the meaning it has for our domain. The same goes for the requested. We had background text gray and text gray, so it's the same, right? But it's not. It's a different concept. The first one is a begin of time span, and the other one is an end of time span. At the moment, they look the same, but they are not the same context. They can change a concept. They can change for different reasons. We can make it visually different, so we made it 2 different classes to make it representing what we actually mean. Then what's left is we still have this border 1 and border green, and we said, okay, when we're in drafting mode, everything that is in draft gets a green border. We've seen that before. So this is true for our whole company. Whenever an application, anything is in drafting mode, it just gets a green border. Instead of calling this class green border, which would represent what it is, we name it what it represents in our domain context. In this context, it is something in drafting phase. So that's better from a CSS point of view, but still, this is just diffs and diffs and diffs. It's not very semantic. Let's extract some of those diffs. So our request is in drafting phase. We have an immutable input that's in drafting, and we have 2 watermark inputs from and until that we can edit. Let's extract those functions. The first one is actually a requested employee. And the other 2 are the need to pick a date. So our draft now looks like, hey, requesting employee with an employee from the model, and now pick a date from and pick a date until. This becomes really easy to read. Now we understand what it represents, because we don't care at this moment in time how it actually works on the front end. Once it's designed, we just need to understand what it is representing. Then we can go inside and see, okay, pick date is just a div with an input watermark in drafting phase that shows me the string for this date, and the requesting employee is an immutable input draft that just shows me the employee name. Cool. The same thing goes for requested. We have the model from and model until. So let's make it in a requested, a vacation request, we show the name of the employee and a from with a date from the model and an until with a date from the model. Now we have clear language representation in our UI. And we just extract the functions and put them where they belong. So the last thing is, how does a CSS look? I'm using Post CSS in this case. So Tailwind is a great collection of the classes you have already seen. It gives me tooling classes. I'm not a big fan of Bootstrap or Bulma or some of those frameworks that tell you, hey, this is how your application should look like. I want to decide how my application should look like. So I'm building everything, but I don't want to build everything from the very first principles of CSS. I want to have some tooling that works well, so I have a set of paddings, a set of margins, a set of fonts, a set of colors, but with all those I can work very easily. And in PostCSS you can just write your class names and even give them namespaces. And namespaces are a great tool to make bounded context transparent. If you have multiple bounded contexts, make it namespaces in your code as well as in your CSS, and then you can just have your classes represent the concepts they should actually represent in that specific bounded context. That means if you have different concepts with the same class name, they get into different namespaces, and therefore they are unique in their respective namespace. If you code like that from beginning to end, your whole domain code, your messaging infrastructure layer, your user interfaces, and even your design up until the CSS classes speaks the language of your business. And no matter what code you read, it always looks like you're understanding what's happening here from a business point of view, and the details are only important while you are creating them. So my usual way of working is not, I'm writing these classes first, that's not what I do. What I usually do is exactly what we did here. I just start typing something until it kind of works what I wanted to do, and then I refactor to deeper insight. Because I don't know what I want while I'm typing, but when I'm doing exploratory programming, after a short while, concepts become clear, you extract them, and whenever you learn more and more and more, you refactor to deeper insight. Because in the end, I want to have code that is pretty easily understandable for the next person who needs to read it. So if I'm asking Kenny now, hey, Kenny, look at my code, can you refactor that? He can just go through that function and say, oh yeah, model request is in drafting, so we're showing a, great. Kind of becomes obvious. So we have the problem of multiple bounded contexts. And as I said before, the visual design, so also the CSS language, belong to the respective bounded context. Shopping has its own classes in CSS and its own behavior and types in the backend. Payment the same, but some things are corporate identity, for example. There is a specific set of rules that is true for every bounded context. We want our software to look the same no matter what context provides the UI, right? If you're Amazon and you have a web shop, the payment provider and the shopping cart, as well as the product placements, they all should look the same. Shouldn't be completely different designs just because of different bounded contexts. So we have a corporate identity, and that in itself is a shared kernel. That is its own bounded context that needs to be shared with all the other bounded contexts that represent information, and those teams need to work together to define or to adhere to the shared kernel. Does that make sense so far? Cool. Okay, so finishing up, what we want to do when we do domain-driven design is we want to code in harmony with the business on every level of building software. We need to be safe from external influence, so whatever changes, it should not break our domain definition. And we need a high internal trust, and this goes from the visual designers to the testers, to the product owners, to the programmers. The whole team needs to understand each other and support each other and work together to a deeper understanding of the thing that we're actually trying to build, better business solutions. So if you want to learn more about domain-driven design, in September there's DDD Exchange in Denver. In Berlin there's Kandinsky in October, and in January there's DDD Europe in Amsterdam. So that's all your chances, and otherwise go on Meetup. Almost every bigger city has a DDD user group. Hit up Kenny, he knows where they all live. And now go forth and live meaningful lives. Thank you very much. So we have thank you. We have a few minutes for questions, if anybody has questions.
Can you estimate how many times it takes to go from a normal code base to what you have presented here?
That's a very good question. No, I cannot, and it depends. So the question was, how long does it take to go from a normal code base to this? A long time. The thing is, it totally depends on what you want to achieve. You will never refactor a whole code base. So we have code that is 20 years old that we will never touch. And 90% of our code still doesn't look like this. There are some aspects of it, some variables that are renamed, some primitive data types are restructured and they are now value types. So depending on core domain supporting, how deep you go into the core, we put more and more and more effort into getting there. And the goal is not to get to 100%. The goal is to get better whenever it's necessary and possible. In my core domain, we put a lot of effort in there. So the things we're building now, they almost all look the same like this. But even in our core domain, there are some aspects where we are like, okay, this needs to ship on Friday. Let's just hack it. So it's working. But then we put a refactoring sticker next to it, and we refactor it good enough so it's understandable, because we all are mature in the team, we all know the code base, and we don't need a deeper understanding. Until it bites us when the next programmer hires in the team, and they look at the code, they're like, what is this? And fuck. So it's an ongoing process of exploratory discovery and getting deeper and deeper. So I think the actual answer is infinitely long. You will never get there 100%, but these are all tools that make your code more expressive, and whenever you feel there's a more value in doing that than cost in changing something, then go for it.
Thank you.
More questions?
Thank you for the talk. One of the examples you showed was your code speaking the language that you speak, so German in your case.
Yeah.
Do you find that that prevents you from hiring people who do not speak German?
Yes, but so there's a trade-off, of course. Good analysis. The benefit of doing that is you don't have to translate every time when you talk to business people, because our customers are people who work in hospitals. So it's people who are professional medical assistants or something. They don't speak English. And if they tell me something, I have to look into the code, and the code doesn't say what they say. Now I have a problem of we have to translate every time. Every new programmer needs to learn both languages because they need to translate that concept. So the domain is German anyway, and in that case, it makes more sense to say let's code make the code in German. If we ever hire someone who's only an English speaker, there's still infrastructure to be done and UIs to be built, and there's a lot of supporting bounded context and all those things where you can put people to that make great, valuable work there in the business. But the domain is a German domain. You cannot even translate most of the business terms because the exact word-for-word translation has not the same meaning in English as a specific term in that domain. So, but there's a trade-off. If you have a company with like 150 employees all over the world, and it's an international team, you cannot effectively work in a domain language if it's not English. Or if you're in Asia, maybe even Chinese, that might work. But like a leading language that everybody shares. So you need to do that trade-off, and then you lose business explorability by reading code, but you gain employability. So that's a trade-off you have to take care of. Sure, it's not for free. Any more last questions? No? Okay, one last, and then he's already saying no more. So make it quick. Yes, you can mix legacy and domain code. Specifically, when you use CQRS and event sourcing, the projection of your new domain code can always project into a read model, but your old database can just be a read model. So whatever happens in the new code, you can project it into the old system, so the old system even doesn't realize that you're extracting something. And then you can build anti-corruption layers around anti-corruption layers until at some point, a whole part is just consisting of protection layers. Throw it out, that part is renewed. So you don't have to rewrite your business software. You can go step by step with it. But it takes effort, of course, because you have to write this projection and make sure it works. And that's not an easy way, not a guaranteed way to make that happen every time. Okay, thank you very much. If you have further questions, see you at beer.